I am Engineer Chamil Edrimuni. I'm the chairman of Electrical, Electronics and Telecommunication Sectional Committee of IESL. So here today, we are going to start our session by this very fruitful, very important topic on energy. The topic is future landscape of energy. So it is my privilege to welcome Professor Harsha Chelaya, the guest speaker of our seminar, and then Dr. Kamal Laksiri, President of IESL, and also the past President, Engineer Priyal De Silva, sorry, Stula De Silva, and then he's a honorary life fellow of the institution, and then other members of the sectional committee and all the participants who are participating online. So let me invite you to a good session of sharing the thoughts. You can also participate by sharing your thoughts, and then you can ask the questions from our guest speaker. So I will introduce him. Harsha Chelaya is a professor in mechanical and aerospace engineering at the University of Virginia, USA. Prior to joining the university, he received his PhD in mechanical and aerospace engineering from Princeton University. He's also a graduate from Mechanical Engineering, University of Moratuwa, with first-class honors. He's a fellow of the American Society of Mechanical Engineers, fellow of the Combustion Institute, associate fellow of American Institute of Aeronautics and Astronautics, and visiting fellow of Pentehouse College, Cambridge University, UK. He is a board member of the Journal of Combustion Theory and Modeling. He will be joining the US National Science Foundation in January 2023 as a program director in Chemical Bioengineering, Environment and Transport Division. So let us warmly welcome Professor Harsha Chelaya for this seminar, and over to you, sir. So you can carry out the seminar with our participants. Thank you.
Yeah. So, use the mic or? Yeah, thanks for your kind introduction. And it's a great pleasure to be here. Last time, can you hear me? So last time I was here in 2019, October, I talked about my research, mostly on this book. Good. Okay. So last time I talked about my research printing, metal printing of parts for hypersonic applications. Today I thought I'll take a different topic, especially after recent energy crisis Sri Lanka. So this is kind of thought-provoking topic I picked. And I've been reading about this topic for a while now. And I think timing is right to explore some of the concepts and see whether Sri Lanka can take advantage of future energy directions. So generally when I give a lecture, I ask questions on the students, but most of the audience is in the virtual space. I'll wait till the end to ask questions. So one question is this on the way? Okay. Yeah. Okay. So I first, before I talk about energy, I want to talk about the in general the energy consumption by the entire world, right? And as of around 2019, the energy consumption around the world is about between 600 to 700 exajoules per year. So exa stands for 10 to the 18, right? And of this consumption, you can identify the sources of consumption. You can break the energy consumption in various ways. I picked a few charts that will help me to create today's theme. So these the data I'm showing today are extracted from US DOE Energy Information Administration (EIA), and they have annual reports called International Energy Outlook Report. So one of these charts are on those reports. So this report shows on the y-axis is the energy units. Typically in the US, we still use British thermal units, unfortunately. But the good thing is that this quadrillion British thermal units, it's one quad, which is usually used in the US, it's equivalent to about 1 exajoule. So it's kind of easy comparison between quad and exajoule, right? And so if you look at the world's energy consumption, the sources, petroleum and other liquid hydrocarbon fuels dominate, right? And followed by coal, followed by natural gas, renewable energy, meaning solar, wind, and so on, hydro, and followed by nuclear. So if you add up all these sources, adds to about 600 to 700 exajoules per year, right? That's the number that I quoted earlier. The good news here in this chart is that coal consumption is going down, which is one of the worst CO2 emitting sources, and natural gas has sort of taken over the coal use for power production. Unfortunately, based on the trend predicted by EIA, it's very slow change, right? Renewable energy has gone up, but according to this chart, it's a kind of slow growth, right? And to change the current trajectory, we need to have exponential increase on the renewable energy in much shorter time frame than shown in this trend line, right? So, which I think it's going to happen within next 10 to 20 years. So this, I'm hoping that this growth shown in this diagram will be completely obsolete. We may have a much higher rapid exponential growth in the next 10 to 15 years. Okay? While the rest will remain pretty much nuclear will play a role, but its growth will not be matched by the renewable energy sources. Right? And in the process, we want to bring down the coal and petroleum contributions to much lower level to cut down the emissions, CO2 emissions from the other source. So that's my theme. So question is, how do you get there? Before I get into look into numbers in Sri Lanka, I want to finish the theme on energy consumption. You can break into again different ways. Power generation is a big concern in Sri Lanka, and if you look at again the world energy consumption, power generation amounts to about 40%. Probably same is true for Sri Lanka as well, right? And all the other uses, meaning transportation, manufacturing, heating and cooling, will add to the rest of the energy consumption. So again, power generation is a significant factor. So my today's target is how do you address the power generation part of the picture. And if you take the power generation, you can now look at where the power generation comes from, different sources. And here, if you look at this based on this chart, it shows that renewable is making a big impact on power generation, which is great news. But again, it's showing a linear growth. But what you need is really exponential growth in renewable energy contribution to the power generation. And if you can have that, in fact, renewable energy power generation might able to bring down the energy contribution for the rest of the energy picture, meaning transportation and heating and cooling of buildings can be affected by renewable power generation. So that's the picture I want to have in your mind. How do you go about bringing down the traditional sources of power, meaning coal and natural gas and so on, and increase the renewable energy, right? So with that, before that, one more last slide on this general scene. To consider the main countries that consume power, China is currently the leading consumer of power, and followed by the Western developed countries, which is part of shown here as the rest of the world. And of course, India is also growing rapidly, so India will have a significant role as well. So we know also the regional consumers of power, and then Sri Lanka, of course, a small part, but I think Sri Lanka can set up perhaps what you call example how to be independent of fossil fuel. Okay? So with this picture, so I pulled down some numbers of power, different sectors, sources of Sri Lanka versus US, right? So again, these are numbers I got from online sources. Numbers may be not quite accurate, but the whole point here is that for discussion purposes, we want to have some relative percentage, right? So here I'm showing the total power capacity. So this first column here is the capacity from fossil fuels, nuclear, hydro, and renewable energy. This is, I think, as of 2016 or 2018, I forgot the date. And according to this, Sri Lanka has roughly 35 terawatt hours of capacity. Essentially, in 2016, production was about 13.66. So I'm not sure, I have a lot of friends in CB, please correct me later. But if this is true, it means that Sri Lanka has way more capacity than its current requirement, right? Which surprised me. And so that's hence the 100% capacity is available. In the US, if you look at the sources, about 70% come from fossil fuel, about 9 to 10% from nuclear, 7% hydro, and about 14% renewable. And again, in US, renewable is increasing rapidly, especially in states of Texas and states like Iowa. Wind energy is being installed in rapid capacity, growing exponentially, right? So that's kind of picture that we want in the Sri Lanka as well. Now, Sri Lanka renewable energy, so hydro is a huge factor, roughly 40-45%. So Sri Lanka is a unique country in that sense. It has a large hydro resource compared to many other countries. It doesn't have such luxury of having a clean energy source. Renewable energy as of this probably coming from wind and solar, it's about 6%. I'm hoping that it will grow rapidly, right? Now, I should admit that the last two columns kind of grotesque. You know, in the US, energy consumption per capita is massive compared to Sri Lanka, almost factor of 20, right? So US has no role of advising countries like Sri Lanka how to conserve energy. But that's a reality, right? As Sri Lanka develops, this number will increase, but for the moment, it's very low number. So taking these numbers together, and so looking at 2016 numbers, this is what I'm a bit confused. About 9 terawatt hours came from fossil fuel, while about 4.6 came from renewable, primarily hydropower, right? And so Sri Lanka, according to this chart, shows about 14.7 capacity of hydropower, yet produce only 4.6 terawatt hours of hydropower. So I don't know exactly what is a mismatch. Technically, if this number is correct, Sri Lanka could have produced all the power in 2016 with pure hydro, which is not the case, right? So again, we can get back to this later. But if you take this number, about 66% has come from fossil, while about 35% from renewable sources, right? And what we want to do is completely eliminate this and go complete renewable, meaning if the hydro is not enough, we can then expand the wind and the solar and provide the remaining power need from purely wind and solar, right? So that's the picture I want to have in your mind. And I think this can happen within the next 10 to 15, probably 20 years time frame. Okay? If you put enough resources and the political will is there, it can happen. So why did I get interested in this topic? I joined National Science Foundation in 2018 before my prior to this my upcoming appointment. I was reading an article on Forbes magazine, and this article says that if you strategically install offshore wind turbines, we can produce 11 times more power than entire world needs, right? And of course, requires about $1 trillion of investment. The point is that if you install wind turbines offshore, we can easily make more than, say, 2 times, 3 times power that world needs. Now, if this is true, which means that we have excess, almost free energy, right? And once you have excess free energy, then you can do wonders, right? For example, so the wind is always has the issue of intermittency. If you have excess wind, free energy, you can use almost cheap, at least I would say, because you have capital investment service factor as well. But you can use that cheap energy to crack water, essentially go to electrolysis and produce hydrogen. And you can hydrogen become an energy carrier. You can store hydrogen in a distributed manner and then use it as wind energy is not available, right? So I think this is a serious possibility going forward. Now, then I look at what are the state-of-the-art wind turbines. This is about 2-3 years ago. The largest wind turbine available at that time was the Halliday X turbine with a capacity of 12 to 14 megawatts. So essentially, it can produce 67 gigawatt hours of gross energy, and this is a massive turbine. So here is the scale of this, the wind turbine, compared to the Eiffel Tower and then the Chrysler Building in New York City. So it's massive. The rotor diameter is about 220 meters, right? But today, there are many other companies making wind turbines of similar class. I think Chinese have a turbine about projected to give about 18 megawatts. And then there are other European wind turbines producing similar wind turbines. So the days of 1.5, 3 megawatt wind turbines soon will be a thing of the past. And G is also working on a new wind turbine that can go up to 25 megawatt hours. Sorry, megawatt of power capacity, right? So if you take that, let's say 10 years from now, Sri Lanka can afford 12 to 14 megawatt wind turbine. And considering Sri Lanka's power need of 14 terawatt hours based on the numbers I showed in my previous slide. And I simply, back-of-the-envelope calculation tells you that 210 GE Halliday X-class wind turbine can power the entire country, right? So you're not talking about having millions of wind turbines, right? And Sri Lanka has about 1,300 coastline, and it's very easily doable proposition. Now, we need to take into account intermittency, right? The load factor. To take 40% is 2.5. So essentially, we need maybe 500 Halliday class wind turbines to power the entire country, right? But imagine not 500, you install 1,000 wind turbines, you could have double the capacity that you need, right? And if you have double the capacity, then you can use excess energy to crack water and generate hydrogen. And hydrogen can be exported. You can use for local consumption. You can export to the rest of the world. So Sri Lanka can be easily energy exporting country with the resources that you have. So this is excluding the hydropower that is already available to Sri Lanka, right? So to me, looking at the simple, back-of-the-envelope calculations, I think if you wisely invest capital, I think this can easily happen within next 15, 20 years. Okay, so that's the picture I want to portray with, on your mind. So I already mentioned that world energy consumption of 600 exajoules, and so if you want to install this 12 to 14 megawatt class of turbines, how many wind turbines you need to power the entire world? So about 2.4 million wind turbines. Okay. And so Sri Lanka needs only 210, right? It's a small fraction. And if the developed Western countries can easily afford to support a country like Sri Lanka, install 210 wind turbines, right? If you are going to install 2.5 across the entire world, I mean, getting 210 for Sri Lanka, I think, very reasonable request, right? So I think if you make our bring our politicians and engineers, scientists together, this can happen, right? The other thing is that if you think about currently, we have about again, this 2019, the numbers I looked at, we have about 600 gigawatts of wind capacity installed across the world. I think it's about 200 in the US, about 200, 300 China, and so on. And then I calculated that, in fact, we need to increase to get to this 600 exajoules. We need to increase about factor of 30, something of that order. Plus, if we add the load factor of 2.5, we are talking about factor of 6 increase. So this is not, pie in the sky. This is a really doable proposition, right? So my feeling is that this is going to happen, whether you like it or not. So might as well jump into the bandwagon and try to, get the resources we need to make it happen. Okay. So the main challenge, the wind, is intermittency. So sometimes in fluid mechanics, we say boundary conditions, right? In this case, it's the intermittency problem. So sometimes it can be days without strong wind, right? So we need to have a backup power. Essentially, storage becomes the issue. Now, storage, this is where the hydrogen will come into the picture. Again, we want to have a clean energy. We don't want to create any polluting, sources, storage mechanism. So clearly, batteries is one option. Tesla already has installed massive farm in South Australia. I forgot the capacity. But talking about 10 to the 18 scale of exajoules is a massive amount from batteries. So whereas hydrogen is a clean fuel, and if you can create hydrogen through electrolysis, it's a clean process, and then you can use hydrogen using fuel cells or using gas turbines to generate power. So to me, it's a much more cleaner, efficient system to store energy instead of a chemical energy carrier, and then you can generate it locally, depending on where the wind turbines are. You don't have to transport a massive distances. You can if you wish to, but you can also do it locally as well. Another approach of storage is water reservoirs, right? You can pump water up to a reservoir during when you have free energy, and then use it as needed. So I don't know, some of Stephen Chu was our U.S. Energy Secretary. He had a very nice cartoon, wind turbine and old water tank, and showing that could be one model. But of course, again, we are talking about exajoules of energy, so that's not an easy proposition. But Sri Lanka has a massive, advantage in terms of our hydro power capacities, right? So you can have a water as a one reservoir as a one storage. Other one is hydrogen. Now, hydrogen has downside. Hydrogen gas, if you store it at atmospheric pressure, it has a higher energy content than fossil fuel for mass, but by volume, it's much, much less because it's a larger volume. So hydrogen has to be pressurized to very high pressure. So that can consume a lot of energy to pressurization, right? Or there is a way to convert hydrogen into liquefied fuels like methanol and methane. So methanol is one clear option that chemical engineers are pursuing, right? So there are options of storing excess wind energy in terms of chemical carrier fuels like hydrogen and methanol, and can be used during the times where they're not in wind energy. So as I mentioned, the cheap, so this cannot be done if you are paying your current rate of electricity and cracking water to make hydrogen. It's a no-go situation. It's very inexpensive proposition. So it can be done only if you have free, almost free excess energy. Okay? So hydrogen can be generated in a distributed setting and use environmentally friendly devices like fuel cells, gas turbines, as I mentioned, for power generation during low wind. Okay? Now, electrolysis can be 40 to 50% efficient. The scientists are working on trying to improve the efficiency of electrolysis. And gas turbine engines also, modern gas turbine engines typically operate between 40 to 50% efficiency. But by going to higher and higher pressure ratio, we can push into efficiency. Also, if you can use that combined heat and power mode, then we can get much higher efficiency. So there are ways to extract more energy of all these systems or make it run more efficiently. But if you combine the effect of generating hydrogen plus generating energy from this hydrogen, essentially if you take 50 times 50% times 50% becomes 25%, right? So if you use this mode, essentially what you're saying is here is that wind energy, you capture it, you recover only 25%, right? But if the wind is going west, 25% is a plus, right? So that's the way to look at it. So it's not, you're paying the full premium price for the wind energy. This is not a proper solution. Okay? So for taking this route, going to hydrogen requires building the capacity to until you get your excess wind availability for the whatever the country or the entire the world. Okay. So what electrolysis systems? As I said, active research is going on in the US, mostly funded by Department of Energy and National Science Foundation. So I'm excited about joining NSF to promote these areas and across the world. I'll show you some work done in Europe in a minute. And then hydrogen storage and transportation infrastructure is needed. There are hydrogen storage and transportation in the southern US, but it's not expensive. Once it's available, then you can use fuel cell driven cars, not batteries, as a source of transportation. So those things will happen in time to come. Hydrogen also being considered for civil aviation, right? So if you think about large jet engine planes like Boeing 787 or Airbus 340, this long duration flight, they're flying 15, 16 hours. I think battery will not be a solution for the moment, right? Even hydrogen will not be a easy solution because it requires massive amount of hydrogen, and hydrogen has to be stored at high pressure. And even if you pressurize hydrogen to say 100 bar, that is about roughly 100 atmospheric pressure, still the volume will be about 30 times greater than a hydrocarbon fuel. So the volume will take larger volume of your what you call aviation vehicle, which may displace a number of seats, right? So those are the factors that people need to take into account going to cleaner sources like hydrogen in civil aviation. So civil aviation is the last frontier in replacing hydrocarbon fuel for practical application. Am I losing connection? Okay. Right. So hydrogen has its downside because of the energy per volume is pretty weak, but energy per unit mass is excellent. So one choice is to, as I mentioned, convert hydrogen to methanol catalytically. Again, catalysis now plays a huge role. You try to convert thermally, it's very energy consuming. So, and in this case, in fact, you can take mixed hydrogen with CO2 and make methanol. Essentially, you can extract hydrogen from the environment, sorry, CO2 from the environment, right? And essentially the way of cleaning the environment, right? So that could be another way of addressing the current environmental, greenhouse gas issues. There are efforts, some folks are trying to convert to methane, but I think it's a more energy consuming approach. I'm not quite sure about we have to calculate the energetics of the process of catalytic conversion of hydrogen to methanol versus methane and decide which is the most best reasonable approach. I want to share with this slide. This is from the Max Planck Institute in Germany, and there the scientists are working on this. Once you have hydrogen, so the image here on the right is essentially if you have solar and wind and other renewable sources, you can feed to the grid, and during excess energy production time, you can feed this electrical energy to a electrolysis system, and you can generate essentially oxygen and hydrogen, and then hydrogen can be combined with nitrogen from ammonia, which is what you call fertilizer, right? And then also you can combine with CO2 for methanol. So they are working on essentially catalysis part of this problem that increase the production of going from hydrogen to methanol and approach. Methanol is a liquid fuel and easily storable, can be transported very easily, and used for many applications, right? So this is a kind of complicated cartoon. I don't have to go into details. Of course, their vision of the future that you have this all sources, wind, solar, and being produced in distributed manner and producing hydrogen. Then hydrogen can be used in refineries and then used in combustion and then produce electricity and transportation and heating and cooling. So this is the vision of the Max Planck Institute in about 10, 15 years. Is what they like to see happening around the world. Okay? So it'd be a nice cartoon to share with people. Now, of course, we have biomass. I should say that in the US has a huge effort on what we call sustainable aviation fuel. Essentially, develop civil aviation, replace kerosene from biomass. They are called sustainable aviation fuels. And then, of course, biomass, garbage is also biomass, right? Can be used, incineration can be used to generate electricity and so on. So there are all other ways of addressing different sources of energy needs. Okay. So I'm close to, my research is funded by Rolls-Royce, and my work is related to gas turbine engines. And I want to point out that the major gas turbine engine manufacturers, Rolls-Royce, GE, and so on, they are in the process of converting gas turbine engines to run with hydrogen. So GE essentially has a industrial gas turbine. They are running now 75% hydrogen, 25% methane, and they like to go 100% hydrogen. Now there are challenges. Hydrogen burns much, much faster, and if you don't change your fuel injectors, you can burn the whole thing down. So they are working on the injector combustor design so that we can go to full hydrogen burning gas turbine engine. So you can think about your Sri Lanka Kalinitissa power plant burning heavy fuel, right? You can eventually, if you have your hydrogen, you can completely switch to hydrogen burning gas turbine engine to satisfy the base need, right? So GE is working on, this is a what you call mid-size business engine. They're converted to run hydrogen, and Rolls-Royce has an engine called Pearl 15. They're also converting to run pure hydrogen. And then there are industrial gas turbine engines, much larger sizes, can run power generation with hydrogen. So these things will be available to countries like Sri Lanka going forward in the future. Okay? I want also to compare the size of the scale of the things, right? So gas turbine is a remarkable engine. Somebody said that it's one of the 10 great inventions of humankind, after the wheel and the nail and the hammer and all that. Antibiotics, for example, right? Rolls-Royce, the largest gas turbine engine called XWB, produces 64 megawatts of power. And this is the scale of the engine, right? There's a person standing in front. It's about maybe 2 times a human being and produces 64 megawatts of power, right? And think about this wind turbine, GE Halliday, is 220 meter diameter, right? The size of a, close to the Eiffel Tower, and can capture 12 megawatts, right? So bottom line is that if you have, say, 5 of these, right, can match the power of a gas turbine engine producing 64 megawatts, right? So that's the scale of the size of devices we are talking about. Of course, always there are losses, as I said. If you take a Halliday wind turbine, you generate, say, hydrogen, you lose electrolysis, lose 50%, right? And then when you go to a turbine, your thermal efficiency could be 50%, right? You will get only about, at the end, 25% total power out. So these, numbers I'm just throwing out that you can do back out on the calculation, have a rough idea how many turbines you need, how many gas turbines you need to satisfy the what you call off-wind condition needs of Sri Lanka. Okay? So what I'm talking about is really scalable wind energy. And also this is not something far out in the pie in the sky. This is happening, right? In UK, I think last December, they produced 50% of the power from purely wind. On Christmas Day, they had 50% power came from wind. So I don't see why Sri Lanka can produce 100% the wind for the country with all the coastlines we have. In Scotland, in 27th, other thing I want to point out. So in Scotland, this is 27 kilometers from the coast in Angus. They have a wind farm called Seagreen. It's supposed to produce 1,000 megawatts of power. Right, this is a 3 billion project, already commissioned. I think they are 25% capacity right now. They're gearing up. When you go to 100% with 50% load factor, they believe they can produce about 1 gigawatt of gigawatts of power, right? And so this is using a European wind turbine, this Vestas 164, the 10 megawatt wind turbine, right? And there are others, and this is operated by the Scottish agency plus French Total Energy. So these are 59 joint initiative between the two privately operated operations. I'm sorry, SSC is I think state, but this is a private company, right? So this is happening. This is happening in real time, and I think that's definitely going to be the future for us. Okay, so my title was energy landscape, and I'm convinced that I may not be around next 20 years, but this renewable drive is going to happen by 2040. I think we'll have a significant fraction of energy coming from wind and solar and so on. In wave, we have not talked about it. We'll have essentially this Forbes article is true. You'll have abundant, cheap, free, clean energy. Okay? So the message, the take-home message, the key message I want for you to leave today is that being an island with about 13,700 kilometers coastline, I'm sure we can find enough corridor to install 200 to 500 wind turbines, right, of the scale of 10 to 15 megawatts, and power the entire country with purely wind turbines. Okay? And combined with hydro, I think we can easily address the intermittency issues. Plus, hydrogen produced can be a energy exporter for Sri Lanka. Okay? With that, of course, all this challenge is capital investment, political will, and that's beyond my scope of expertise. I hope anybody around here, able to make it happen. Now, I'll be happy to help anything I can do on the US side. And of course, there are public philanthropic organizations, Bill and Melinda Gates Foundation. They have energy interest as well. So there are other sources that people can approach as well. So with that, let me stop and take any questions you may have. There go time.
Thank you, Professor, for your insightful presentation, which actually have targeted the future energy, I would say, yes, the landscape, actually the future, what should be. You have focused mainly, you have faith in wind power, and also the hydrogen storage, the hydrogen production and storage. Actually, on behalf of sectional committee, I would like to thank you for giving up this great presentation with a span of 40 minutes. Now, I will open the forum for the questions. So we have the participants, in-house participants, and also the participants from the Zoom. So they can have the questions. So I have thrown the how you can ask the questions, because you can raise your hand. You can use the raise hand option, and then our host will unmute you. So by that way, you can clear your voice, and even you can message via this chat box. Yes, Dr. Deva Surendra raised the hand. If the host can unmute Dr. Deva Surendra.
Yeah, sorry, it's a fascinating speech. Anyway, now the thing is, I'm a mechanical engineer myself. Now, the thing is, they've been talking about storing hydrogen in salts. This was in the last IMEC journal. So they say, I have this thing here. I think probably you can. I don't want to read whatever is there. They found that converting bicarbonate and hydrogen into formate and vice versa was the most effective. Was most effective with potassium salts and so on, right? I mean, it's a long story. I don't want to repeat whatever is being done with some German university which is doing it. I mean, probably they say they can store hydrogen large scale and kind of, you don't need this hundreds of atmospheres of pressure to store hydrogen and so on, right? So that's one thing. You didn't touch on it. I probably these are research things, right? So it's one thing. So while I have the chance, I will ask a couple of questions, right? Second thing is, if you have a large number of wind farms all over the place, now you can have them, but then maintenance of these things, and they will have a lifetime, right? I mean, it's a highly corrosive environment, right? And hazards, right? All kind of things, right? So those are the other things, mechanical wise, right? And you never wanted to say anything about nuclear, which is again, I mean, there are the hazards, but which is also clean, right? You can listen. Now you can have 500 megawatt nuclear plants nowadays, right? So even smaller. So of course, disposal of this, I mean, spent fuel is a problem. You can't think there, right? But well, those are the things that I want to ask. Sorry, I don't want to go too far. Yeah.
So can you hear me?
Yes.
Yeah.
Yes, I think you can.
So yeah, these are very good, valid questions, comments. Hydrogen storage, DOE has done a lot of work on storing on metal hydride, and all the thing is all just add to the weight, right? So if it is a ground application, they are very good solution. But if you want to take hydrogen for, say, civil aviation, the weight factor becomes a huge issue. So yeah, you're absolutely right. The people are looking into different ways of storing hydrogen on metal hydrides and other stuff. So this is ongoing research. On the question on nuclear, yeah, it's a good point. I mean, nuclear is not going to go away. France is a country has 70% of energy from nuclear, and what Germany has gone away from nuclear completely. Japan has gone away. So there are all different models around the world, right? But US, we are about, I think, I would say 10%. So it definitely can. So I don't describe one solution. There are going to be mix of energy solutions, right? But for a country like Sri Lanka, I think we have to pick and choose what is the most suitable energy source that we can get, right? We don't have any nuclear for the moment. And I think, to me, if I want to invest money on something now, probably wind seems to be the most logical way to go. So it's up to, scientists and engineers to sit down and discuss all these options. And of course, it's all cost factor come into play, right? And then you brought up the issue about service. Offshore wind turbines are clearly a lot more costly to service than on land wind turbines. But the problem on land wind turbines, that people don't want to have, not in my backyard syndrome is there. NIMBY effect, right? So the further you can go away from the shore, the beaches, people have less objection, right? And so to me, that's probably, especially Sri Lanka, people value their beaches and the view and all that. So further you can go away from your beach front, I think will be a safer bet. There'll be less objection. So these are considerations that as country make a decision and investment on which approach to take.
Thank you very much.
Thank you for that question. I think the voices or the challenges and objections. I think maybe if you are going to the moon, even there will be objections. In Sri Lanka, you find many objections. Actually, I would like to clear my voice a little bit regarding 100 megawatt wind power plant, which was a Sri Lankan product. I mean, it is a Sri Lankan property, so that it was built by Ceylon Institute Board with the assistance of manufacturers. So there are many objections. So I think the way for that should be even that we are going to have the renewables into our systems. So the objections and these challenges should be avoided by the government. So government has much role to play even. And on that part, I also have one question to you. You have not touched solar. So solar is definitely a prospective source of energy. So what about that? Any thought of solar?
Yeah, I mean, solar is, I don't know, that Saudi Arabia, they claim that they'll be depending on 100% solar in next few years, right? Although they are biggest oil producing country, they want to go pure on solar power. So they have the land, I mean, they can do it, right? So again, depends on your country, the geography and all that. And in my house, and I can show you, I installed solar panels just about 6 months ago. My old house was not a good location, a lot of trees. And I moved to a new place. And I'm generating 1.2 megawatt hours of solar power a month. And I'm exporting right now, right? So if imagine every house you have solar panels, your consumption will go way down. So I don't know, some of you know the duck curve. In California, they have what you call energy consumption called a duck curve, because daytime, the power need from the power companies all goes to zero almost, because almost everybody has solar panels on their houses. So they're exporting power. And then morning and the evenings, nights, you need the power. So then it's a shape like a duck, right? So solar is a clear pay factor, but for countries like US, manufacturing, consumes so much energy, right? And so that we have considered solar power plants, and they takes massive amount of land compared to the wind turbines. So it's a balancing act. You need to figure out the land, geography, availability, cost factor, and all that. Right? So yeah, well, it's going to be a mix of everything.
Yeah. Thank you. Any questions? Yes, I think there is one question.
Yeah, thank you for unmuting me. I'm Indika Dasanayaka. My question is now, you said earlier also nuclear was mentioned. And when people talk about nuclear, they generally mean fusion. But now research is being done on fission, making helium out of hydrogen. So I have read somewhere that there are some experiments which are showing promising results on small scale nuclear reactors using fusion, which will be less environmentally troublesome.
Right.
And if we can use this sort of hydrogen, yes, directly connecting the wind turbines to the grid will be definitely causing problems for a country like us with a small and weak grid. And what sort of developments are going on this sort of fusion reactors in USA?
Right. So
Thank you.
the joke is that they say every 10 years and every 10 years goes another 10 years and the goalpost being pushed every 10 years and so on, right? So yeah, there's some positive progress is there, but when it will be available on large scale is questionable, maybe 2060. So the forecast is currently, if I recall correctly, 2040, 2050, so the long time frame. So my feeling is that that's why I specifically mentioned I want to focus on what is available now, right? And what are the scalable technologies available for a country like Sri Lanka for the moment, right? So, I mean, we've gone through some energy crisis now, and if we have to invest money, I think you have to be realistic as well. And these are great choices, but it'll take time. And why not capture on available technology, which is being scaled up rapidly across the world? So I agree that all these are good options. Nuclear, fission. I mean, it's really a good choice. But I think from my high energy physics friends, it's essentially the timeline is being moved.
Still too early.
Yeah, exactly. Yeah.
Okay. Thank you.
Thank you for that question. I think Mr. Aruna Ranavira, you have raised the hand.
Yes, thank you. Can you hear me?
Yes,
Yeah.
yes, loud and clear.
Yeah. Thank you, Professor Chalaya, for the excellent presentation. I see a lot of mechanical engineers working. I mean, I myself is an electrical engineer. So to give, a little bit of, electrical engineering perspective of this one. I mean, what you said is true in terms of the number of turbines and so on. Let me first introduce myself. I'm here in the US. I'm in the interconnection area in Hecate Energy here in the US, and we do have a lot of wind development in Europe as well as in the US. We have. I mean, we are considering these turbines like the GE turbine you mentioned, right? So just to mention, and we have looked at the Sri Lankan offshore possibilities too, and there are some proposals as well. So just to let you know, I mean, just to give some numbers into your numbers. So I think you mentioned, I mean, the by 2030, I think Sri Lankan, the power demand in megawatts could be, I think, something like 8,000, if I recall correctly. It's in their long-term generation plan, right? So if you consider 8,000, and then each turbine, you have to put a capacity factor, right? Like I think, but that's what you meant by load factor,
Right.
About 40%, 50%, and then. So basically, what I'm trying to say is you need a lot more turbines than what you mentioned. But that's not I mean, I'm not saying it. What you said is wrong or anything, right? Just to, this is good. I mean, the engineers, they know electrical. I mean, CB engineers, they all know this. So that's a good. I think people should think about this. Hydrogen future. I think Sri Lanka can be.
Excuse me, your question, Mr. Aruna?
Yeah, I just want to. These are some comments. So just to provide some comments. Okay.
Yeah.
Right.
So
right.
I
Thank
have
you.
a question for you.
Okay.
What is the cost for kilowatt installation of a, say, 10 megawatt wind turbine? Do you have a number?
We don't have a number like that, but generally for 2000 megawatts, I mean, we consider some approximate number, in like 1 to 2 million. I would say about 2 million per megawatt. So that's how the numbers are,
Okay, so 2,000 per kilowatt hour, so to about 2,000 roughly, 2,000 per kilowatt installed capacity. $2,000, I mean, right?
in megawatt hours, right? So yeah, so per megawatt,
Okay.
it's about, yeah. I mean, these are, I mean, just high level approximate number, 2 million per megawatt, right?
Yeah, I'm just curious to know, since you're in the industry, yeah, knowledge,
Mhm.
Installing these at good to know a real number, so, okay.
Yeah, so yeah. The real numbers depend on the depth of ocean, right? In Sri Lanka, there is some, the closer to the shore, the tower height would be less, right? So things like that. Yeah, it depends on whether you go to
Yes,
the real.
thank you.
Thanks.
I think we got to give the chance to others. Thank you for your valuable ideas. And then Dr. Devasurendra, sorry. Yes, Dr. Devasurendra has another question. Yeah. Can the host unmute Dr. Devasurendra?
Sorry, so you gave me an answer for the question about maintenance. What's the kind of lifetime of these wind generators? Because I have visited some of these things in Putlamanol. We go and visit these plants. They're massive, very impressive structures. But what's the kind of lifetime you would give? Because there is always, you see now, you'll have to cannibalize them, right? One fine day, right? And then you'll have to, because when we visited the Putlam farm, they were already dismantling some of the, some of the windmills, right? The massive ones. Now, so the cost factor, right? Because if it's in the middle of the sea, right? Now,
Right.
I mean, listen, I've just tried to tell us some practical things about these things.
Absolutely, yeah. So I'm not expert, and
Yeah.
my CB friends probably know more about it. But these are the things that we need to analyze. Service cost, capital investment, right, and the lifetime. So I mean, everybody wants to recover their capital investment, typically in the US, in 4 years, right? And then after that, they want to make the money. So you need to be at least, the device has to last at least 10, 15 years to make money, right? So if you go with a private investor, they want to recover their capital investment in typically, I don't know, 4 to 5 years. That's the mindset they have. So you've got to have a lifetime way beyond the capital recovery period. So these are the factors that we have to, take into account. But clearly, point is that countries like UK and others are installing these on offshore locations, and they won't. I'm sure they won't do it without considering all these factors, right? So we have to pay due diligence to understand all these factors, but I think it's a proven scalable technology that is available now, and maybe it'll get cheaper by the day. So I think we should think about considering such solutions, I think, right? So that's the message I want to give across. But yeah, I agree 100% that we have to be cautious about. And then, if you go with a venture capital investment group, they have to make money, right? So you have to worry about that too, so you have to be realistic in your expectations. So, but young folks in the world are concerned about the environment, right? So I think environment is very important, I think, for many people. So I think you have to weigh all those factors in making our decisions.
Any other questions? Yes.
Yeah. That's easy. So it's just like any current cogeneration plant, right? So essentially you change the fuel source from say natural gas to hydrogen, and then you can use for heating and cooling, same as the thermal cycle will generate the electricity. The excess energy you dump to the environment can be used to run heating or cooling. So Sri Lanka, unfortunately, doesn't have a huge heating need, but you have a cooling need, perhaps, right? So Sri Lanka, it's not a perfect place to take massive advantage. I mean, smaller scale maybe okay, but you have massive, we talked about a 25 megawatt turbine. Um, I don't know what the heating uh, is used for in Sri Lanka. So a Kalanitista power plant, do you have cogeneration here? I have not visited the facility, I don't know, right? So, but the US is very common. The universities, some universities have tri-generation plants. So University of Connecticut, for example, has a tri-generation turbine, the 3 turbines, solar turbines, and they use power the entire campus with the turbine, and then also do the heating and cooling as well. So the switching the fuel, just matter of changing your turbine to handle hydrogen fuel. Yeah. Right. The boilers typically they're used for in the winter for heating all the buildings, and the summer use the cooling part to cool the buildings, right? So that's the typical operation mode in the US, the tri-generation system. Yeah.
Yes. Another question from participants. Are there any more? Yes, since you are from USA, now you are a resident of USA. They have USA is not a signatory of COP27, also the Paris Agreement. So I think they need other nations to cope with the environmental mitigations, and maybe they are doing. But the thing is there a notable sign of intervention for mitigating this global climatic change? Then thing like this.
Yeah, I'm not a politician, so this is all politics, right? So I would stay away from the politics. Yeah, I mean, it's pretty sad, but it's politics coming to play, right? So yeah, many things that US could be doing, but yeah, so, sorry, I'll stay away from politics. Yeah.
We will not let you in that position, but the thing is one president comes, then they are telling that they want the coal, and other president comes, they will shut down the coal power station. So there are many things. So we can take out of those policies. So so we can let 1 or 2 questions, and then yes, chat. Okay. We'll check. No, there are no questions, but their views are there. Thank you. Yes.
Yeah. So, I mean, Germany is a big manufacturing country, right? So they're like US in the energy sector. So Sri Lanka is like more, I would say, we are a developing country, right? Our need for the manufacturing sector, energy needs not as much as say Germany or the US. So Germany has a massive need for their manufacturing capacity, right? So hence they have lots of gold like um, east of say Frankfurt, you see lots of wind turbines, but I'm not sure they're developing enough power to support their manufacturing complexes, right? Hence, they need. I mean, they had nuclear. They went away from nuclear, and they were going to rely on natural gas. Now they're having problems with that, so hence they went back to coal. So I don't know what their future plans are in terms of addressing, environmentally clean energy sources, right? But, I don't know what the German plan is, but the scientists there are working on this using hydrogen the rest of the world. So they are developing technology for the rest of the world, right? So with the way I see that Sri Lanka could be a country, be a nice test case to show that small island can be totally energy independent, and we can in fact exporting energy rest of the other parts of the world, maybe India. India needs a lot of energy. We can export hydrogen to India and have a pipeline to India. So I think it'd be a nice role model for the world to see this is a small test bed that with wind we can develop all the energy we need. Combined with hydro, you have storage, right? And you can produce hydrogen and do all kinds of things, interesting things. That's the way I see it. Comparing Germany and Sri Lanka as apples and oranges, very different situations, right? Yeah.
Okay, I think it's time to wind up if there are no questions. Yes, I think it is time to wind up our technical session, actually a seminar on future energy landscape. I think we have done justice.
Yeah. Thanks
and
for attention and for nice questions. I think hopefully managed to answer. I'm not expert. This is not my research area. I ventured way outside my research area, but hopefully, people think a little bit more about future, especially younger generation. That's why when I teach thermodynamics, I tell my students, I won't be around to see this happen for your generation. Yeah.
yes, thank you.
Sorry, one last question. I just wanted to.
Yes.
Okay. I raised my hand. Now the thing is, Professor Chella, yeah, I'm the Surendra again. Right now, sorry for. Now the thing is, we are totally dependent on technology. You should know that. Listen, now we can be independent energy-wise so long as somebody comes and install these machines and come and repair them for our sake. But then the moment they go down, even in Norachole, we have to wait till the Chinese come and do the job for us, which is a shame. Now, when we have a large number of plants like that all around the country, listen, will you? I'm a mechanical engineer. I love my mechanical engineering. I love my engineering. Listen, I did a PhD in electrical engineering school, right? I'm a retired guy already. That I have seen through the thing, right? Now, the thing is, now we can be energy independent for a little while, but totally technologically dependent on whole host of companies who will be asking for the pound of flesh, right? Now for doing the flimsier stuff thing, right? Because we are not developing our capacities, we are not developing our capabilities technology wise. So there is a downside to all these things unless we develop our capacities. Unless now that is the most important thing, to be able to stand on our 2 feet, you see, a collective 2 feet, if you like, right? So I think you get the point, right?
Yeah. So yeah. So we need to educate our next generation of engineers and scientists here, right? And we need to keep them here and get engaged in these technologies. So I think that's as a part and parcel. I mean, companies probably like to go to countries like Sri Lanka because of level of education. So I think hopefully you're smart, we can get our young people to be knowledgeable about maintaining these devices and, get involved in the process. But we won't be, you're right. I mean, we don't have the probably the, you know, venture capital needed to, but, I think our people can do some fundamental research at the university level. And of course, they'll go abroad, we can learn, and some will come back. And people like us, we like to help any way we can. But I mean, I get your point. I mean, I was as an intern, I was at the Satakaskanda yarn factory, which is donated by Japanese government. I remember this is 1981. When the ball bearing goes down, we had to wait for the ball bearing to come from Turkey or Japan, right? And it's a very costly proposition. While you could, go to Maradan and buy a ball bearing, but no, you have to wait to come from Japan. So that's the kind of agreement. So those things happen, right? So we need to figure out how to overcome, come up with smarter, how to handle those situations. So I think I heard the same story with the, the Chinese, coal power plant. Yeah, so valid point. Well taken, yeah.
Okay, then we will wind up now. I would like, it is my privilege to invite Dr. Kamal Laksiri, President of IESL, to give away the token of appreciation to Professor Harsha Chelaya for his valuable lecture today.
Thanks, Kamal. Thanks. Yeah. Hope. Yeah. Yeah. Okay. Yeah. Thank you. Yeah. Yeah. Thanks. Appreciate it. Yeah.
And now I call upon Engineer Prasad, member of the Electrical Sectional Committee, to give away the thanking note and closing remarks. Over to you, Prasad.
Okay, good evening, all of you. Today, our guest speaker, Professor Harsha Chelaya, I'm taking this valuable time to thank you because your time and your busy schedules, you have been here. So, I think all the engineers who participated in this event got chance to get the new trends in the energy sector also. Thank you very much for being with us, sir. And Dr. Kamal Laksiri, President ISA, thank you very much to give us guidance to deliver this type of knowledge sharing sessions in our country and our ISA, sir. And thanks, Engineer Chula Bizila and Engineer Gunardhan to participate in this event also. And Neil Abhisekar, CEO, thank you very much, sir, to give us the these premises. That means this is a newly built Navsiru studio for conduct this type of knowledge sharing sessions. Okay, and then I like to thank Chamil Dirmani, is the chairman of Electronic and Telecommunication Engineering Sectional Committee, and all the members who participated today. I would like to thank you very much, all of you, and we can conclude the session now, sir. Thank you very much.